Hello, everyone. I'm Mike Heroux, and I'm one of the organizers of the 2021 Collegeville Workshop on Scientific Software, with an emphasis on software teams. And one element of the workshop is technical approaches to improving software teams. And there's a very nice white paper submitted to the workshop program by Jacob Moxley and Reed Milewicz. I'm here today with Reed and Jacob to cover some of the highlights from that particular paper. Maybe first, if you don't mind, both of you, introducing yourselves just a bit.
Thank you very much, Mike, and nice to be sitting down with you.
Yeah.
I'm Jacob Moxley. I'm a student intern at Sandia in CSRI this summer. I go to the University.
And CSRI is what, just for the audience, if you don't mind?
Computer Science Research Institute.
Thank you very much.
Yes, and an applied math and chemical engineering student at the University of Colorado.
Yeah, very good. Welcome.
Hi there, and as for me, my name is Reed Milewicz, and I'm a senior member of technical staff in the Department of Software Engineering and Research within the Center for Computing Research at Sandia National Labs. I do a lot of research in the areas of software engineering, formal verification, compilers, and all that work is focused towards developing better practices and processes and tools to support scientific software developers. I'm very interested in doing more and going farther with scientific software.
Yeah, thank you very much. Thanks for both of you. And Reed, sorry I didn't get the right emphasis on the syllables in your last name.
Fine.
After all these years, do you think I'd be able to do that pretty well? But I keep messing it up. Okay, so you have this very nice paper. I really like it, and the title of it is "Encouraging Pride in the Tools We Use." And in the first paragraph, you allude to the phrase, and I'll just quote it here: "A farmer is proud of his tractor and works to understand how to repair it and customize it to his or her own needs." Can you elaborate a little bit on that correlation?
Absolutely, and I think the key words for me at least are an extension of your professional self. So tools are an extension of your professional self. A farmer is going to realize that they are intimately tied up with their tools. It's what's keeping the lights on. It's what's feeding their family. And so that pride in their tractor, in the tools of their trade, is really vital for lots of technical fields, be it farming, plumbing, an electrician that likes their multimeter. And so in a computer science world, we can become a little bit detached from our tools. We might not take so much interest in the inner workings or the focus of the team that built the scientific software that you are now using. And so we can and should enculturate the pride in those tools for ourselves.
Yeah. Very good. Thank you. Thanks. Yeah. Reed, do you have further, please? Yeah.
Yeah, I would add that this isn't a foreign concept for scientists, right? We have had a long history of taking pride in our tools when it comes to the traditional instruments of physical experimentation, right? When it comes to telescopes or spectrometers or what have you, right? But at the same time, software, which is this relatively newer thing that we're still trying to grapple with and understand how it fits into our work, into our careers, and how we should value it, to what extent, right? There's a lot more room for us to explore these concepts and figure out, well, what is it that we value about the software, and how can we encourage the things that we do value?
Yeah, very good, very good. Now, you go further to talk about some of the key elements that make for good tools, make for useful tools. And the first thing you mentioned is documentation is key. And you mentioned Project Everest. And so maybe generally you could talk a bit about what you mean by documentation is key. Maybe speak a little bit to the Project Everest piece.
Absolutely. So Project Everest, which is a very interesting group that I would advise anyone to go look at, is attempting to build a formally verified web stack. All of the security protocols, all of the HTML, CSS, all of it. And so the point that we were trying to make with documentation is key is that documentation is kind of an unambiguous. I really don't think there's a lot of disagreement about good open source documentation is key for people to pick up and use new software. In my opinion, as someone from an applied math background, this is extremely exciting from a formal verification standpoint. I think Reed will also speak to that. If you start with some of the aspects of your programs proved for you, then it's a natural extension to prove your own implementation. And so this creates kind of a virtuous cycle where if we go out and value and use tools with good open source documentation, with good formal verification at the start, then we can contribute back to that as well.
Yeah, very good.
And to that point, and I think this is a general theme in Jacob's paper, the ideas that he's put forward, is that we're looking at quality, like software quality, both from a consumer perspective as well as a producer perspective. Oftentimes we think about ourselves writing the software, right? But not so much about as a consumer, even just consuming other people's software. There's been numerous studies on this front, like in the conventional software realm, about who uses which tools, right? What software tools do you use? And it's oftentimes on the basis of external signals like popularity. Oh, everyone else is using it. Surely it can't be that bad, right? But we have to there's an opportunity for us to think about, well, what do we want to see in the software that we use, not just the software that we produce? And there are things that we can meet in the middle, I think Jacob points out here, where it benefits both the developer and doing their work as well as the external community that they want to attract, documentation being one of those.
Yes.
And just to go one step farther on what Reed's saying, a lot of this incentivizing does come back to an economic rationale. And so some of these things can sound like afterthoughts or, oh, that's just more money and more time that we need to spend on documenting something that if you just read the code, you would kind of automatically understand. And the answer is to expand and take what I call an optimistic view of the reach of of the science that you are trying to build on top of this software. Let's assume lots of people want to pick up your work long term. And that optimism means that you should explain it in as broad a sense as possible through good formal documentation, through strong mathematical proofs, through strong examples in a variety of fields.
Yeah, very good, very good. Yeah, it reminds me of an old story, but I'll share maybe a bit that very early on in my career at Sandia, our users were used to just pulling up a source file and looking at whatever terse documentation was there, right? And so then we tried to elevate our quality, and we started using Doxygen, the markup type of approach, right? And some of our long-term users were saying, I don't like this Doxygen stuff because now when I bring up the source file, it's got all this other prefix stuff in it. And our point was, no, go look at the pretty white website now that it just got generated. So anyway, small little anecdote. So next you talk about open source, and for open source for everyone is the title of that section. I'm particularly interested in you point to Rust as a really good example as the gold standard for integrating proper packaging. Can you speak to that a little bit?
Absolutely. So I think that the answer, open source is for everyone, and we get into this in the paper a little bit. That doesn't mean that every project needs to be open sourced every single time. It means building that as a goal from the start every time, and making things in a way that you could open source them readily if that was what you wanted to do down the line. And so there are lots of tools out there. There are lots of great modern tools that have made this a focus, and packaging, and we get into this later with interoperability and modularity, is a very big part of this. And so as someone that learned Rust on the internet as opposed to a formal class, Rust does a great job in the Rust book with Cargo. Cargo has its own book, and for those who don't know, Cargo is Rust's package manager, and this really allows this encourages the instinct to publish. It doesn't force publishing. It simply encourages the instinct. It allows someone, it instructs you as a default to build even very simple, straightforward things. Create a new environment, create a dependency tree within that environment. If you simply put things in the scaffold that we have helped you build each time, then you can readily go and have interoperability with other types of Rust packages.
Yeah, very good.
And it is interesting you brought up Rust in the paper. I myself was recently attending a workshop specifically on the use of Rust in high performance computing contexts, and the promise of like new languages like Rust and delivering features like static memory safety and so on. But to the point about package management and such, the point that I would want to second here with what Jacob just said is that the easier that you make it for people to share, right, to share their code, to make it accessible, the more traction we're going to get in terms of pushing for open science more broadly, right? Yeah. You want to lower the opportunity costs involved in having to put something out there, right? And I actually give a little presentation series now and then on how to write code you're not afraid to share, right? And that it's oftentimes fear. They're afraid,
yes,
you know,
right.
and
Absolutely right.
They're having to do all this themselves. And I think that the easier we can make that for them through better tools, better processes, better technologies, like what they have in Rust, for example, the better off we'll be.
Yeah, very good. So you have a section entitled Agnosticism All Around, and it says the third piece that we can try to generate pride in is the concept of hardware, operating system, and operator agnosticism. And at first glance, that may seem in contrast to your original statement about pride in a specific tool. Can you explain how those two things can coexist?
Absolutely. And so earlier in the paper, and I do feel this. The goal is not to instigate dogma. It's to come up with these things in a very straightforward way, and to provide. It's incumbent upon us to provide genuine reasons to back these things if we're going to put our money where our mouth is and say, well, as a consumer, encouraging a culture of open science is important, and indeed it is. And so the answer is that this really gets back to the reproducibility. And so you can take great pride in the things that you build and consume, but only insofar as they're reproducible. And so and we go into this, one of my favorite examples. This is a very controversial topic, and I'm not trying to take a strong stance on it. The OAS report on Bolivia, which was done in a very open way. And so it's the openness that I think is very heartening to see there, where we've got this extremely controversial topic, and the software and data sets behind it are made completely open source. And they are critiqued from people all over the world using different machines, different operating systems, different operators. And it's the agnosticism that allowed them to successively critique and improve these different tools that they were using to try and analyze that the OAS was analyzing the Bolivian election.
Yeah, very good, very good. Thank you. That the last major topic is modularity and interoperability. Can you say a little bit about that topic?
Certainly. So modularity is something that I think is a general concept that's helpful for lots of people. And the answer is you want the tool in your toolbox that does the most things. And so repurposing parts of different tools is what enables people to engage in translational learning. And this has become the focus of a lot of machine learning, because it's such a difficult thing, and it's such a human thing. We take the thing that we learn over here, and we come to view problems in a different way so that they become compatible with each other. Right. And that process is enabled by modularity. It's taking that tool and repurposing it for that different problem. And so the different modules and submodules that you see in things like Python or Julia or any of a number of languages enable that modularity. from a scientific computing standpoint, this is also very useful, for your figure of merit. It's speed. It's usually just how fast is the machine cranking it out. And so what that means is having a lightweight core and taking just the things you need with it. And so modularity enables that figure of merit there.
Yeah,
Reed?
very good.
And to that
Reed,
point,
go ahead, please.
I would just add that in my experience, to anticipate some counter arguments that I've seen. I know people will say, I know my code is ugly and it's a spaghetti code, but it is fast. And I'm afraid if I make it not ugly, it'll no longer be fast, right?
Yeah.
But the reality is that looking into the numbers, you'll find that like 80% of your performance comes from 20% of your code. You have certain computational kernels that need to be very tightly, put together and operate in a certain way. But for a large code base, it has lots of features. There's lots of room for decomposition and modularity in order to make the system healthier, easier to work with, easier to test, easier to extend and share, and for other people to build off of it, right? And to the greatest extent possible, we should value that, both in the software we create ourselves, but also in the software that we choose to use, right? That this is something that I myself am becoming more conscious of when I say, oh, this software package looks nice. I think I can use it for my application, for my research, right? But at the same time, I have to think about, well, what technical debt am I inheriting by making this choice? Like will this thing be working 6 months from now? Is it going to be stable and extensible? What if I need to add to it or modify a feature, right? How easy is it for me to do that? Those are all considerations that I think we should all be asking ourselves.
Yeah, very good, very good. Well, thank you. So any last minute comments you want to make based on our conversation?
Not that I can think of off the top of my head. I will say Reed has also been working with another intern, Han Young Wonro, and they're going to look at a more analytic framework for trying to measure specific figures of merit. And so,
very good.
The only thing that I would say is that I enjoy kind of the adaptable higher level concepts, but drilling down into specific figures of merit is also an important piece of this. And I hope that other parts of the Collegeville workshops get into the specific figures of merit and into kind of the nuts and bolts of it even more.
Right. But I will say, though, I do not want to discount the value of having the right message and looking at the problems in the right way. I know that many of the, I do a lot of consulting with scientific software teams. I know many of them are very data-driven people, right? They want to see impact, they want to see numbers, but you also have to figure out how can I, align software quality goals, like the things we want to achieve in software with the things they want to achieve in their career, right? Because at the end of the day, they want to do science, right? And you have to figure out ways to say, I want to align that with achieving these things in the software engineering realm, right? And there's not that alignment, that fit, right? It's not going to succeed, right? And I think by making the case, and I think Jacob does a very good job at this, of making the case that we should value certain things because it connects directly to our careers and to our sense of professional pride and sense of identity. And I think if we can sell people on that, that goes a long way towards making culture change happen.
Yeah, very good, very good. All right. Well, thank you very much, Jacob and Reed. I appreciate you taking some time, and thank you for your contribution to the workshop. I appreciate it very much.
Absolutely.
Bye-bye.
Thank you for taking the time to talk to us.
Yeah, very good.